Today we're going to take a look at quadratics and three different forms of quadratics. So all of these three are pretty familiar to you. We've worked a lot with standard form. Intercept form, you'll notice that's with the parentheses, but you'll notice we have this A pulled out in front. And then vertex form again, and you guys recognize this from last, like as shifts, we move it to the right H and up K, where this is our vertex, but our vertex just happens to be H and K. So that's one of the things we're going to talk about down here is vocabulary. Well, here it's really easy to find your vertex. To find your vertex from standard form, you might remember from last chapter, x equals the opposite of b over 2a, and our y value, we just plug in x, whatever we get. Well, when you think about intercept form, let's say if we know that these are two intercepts, our vertex down here is right in the middle. So the x value, so let's put vertex again here. And the x is in the middle of the intercepts. And to get our y value, we plug in x. So we've talked about our vertex. We can talk about the y-intercept. And for all of these across the board, it's the same. X equals 0. So straight across, so to find that, we're plugging in 0 and finding some y value. So there's our y-intercept. The roots, our roots in this one would be P and Q. And if it's in standard form, we have all the different methods, our 4 different methods for finding them. And if it's in vertex form, we're going to have to convert to standard or intercept form to find them. And so those are our x-intercepts as well. In the axis of symmetry, all that is that line going right down the middle, is the axis of symmetry. Because we know if a point here, maybe it's 2 away, there's got to be another coordinate that's also 2 away over there. So that's why it's called our axis of symmetry. So today what we're going to do is we are going to go through several problems converting back and forth between different forms. So when we look at it right now, this is in standard form. So we have standard, vertex, and intercept. So we know our standard form, y equals x squared minus 4x minus 5. Now let's see, intercept form. Well, that's kind of like factored form. So what multiplies to -5 and adds to -4. So that's going to be x minus 5 and x plus 1. And now let's think about vertex. There's 2 different ways we could do vertex. We could try completing the square, or what we can do is we can use our knowledge that we know that x equals the opposite of b over 2a. So that would be 4 over 2 times 1. So that's at negative, or at 2. And then if we plug that in, let's see, so y equals 2 squared minus 4 times 2 minus 5. So 4 minus 8, -4 minus 5 is -9. And we know our a value is 1. So our vertex form would be 1 equals 1. X, since it's at positive 2, minus 2 squared minus 5. So if we're to graph this, where are our intercepts? Well, x is 5 and x is -1. 1, 2, 3, 4, 5, and -1. And let's see, we know our x is 2, and that makes sense. That's right in the middle of 5 and -1. So 2 and -9. And then the other thing it says is the y-intercept. So what is our y-intercept here if we graph it? Well, again, that's 0y. So if we plug that in, 0 squared, 4 times 0 minus 5. Well, our y-intercept is at -5. 1, 2, 3, 4, 5. And we know that this is an axis of symmetry, so we could add another coordinate, 1, 2, 1, 2, because then we can make a nice accurate parabola here. All right, so this next one here, all three forms, well, this is intercept form right here. So let's see, if we need to put this into standard form, let's see, we got to multiply this out. So y equals, let's see, 1/2 x plus 1/2 times x minus 5. We do some distributing here, so 1/2 x squared minus 2.5x plus 0.5x minus 2.5. So y equals 1/2 x minus 2x minus 2.5. So here's our standard form. And then we need vertex form. Well, a couple different ways we can get our vertex. We know our intercepts are -1 and 5. So our x-intercepts, -1 and 5. So -1, 1, 2, 3, 4, 5. This is looking awfully similar to the one before. Let's see. So we know our x value has got to be right in the middle. So it's got to be at, oh, I think I did that one at 4. I'm sorry. I have a hard time counting on here. 1, 2, 3, 4, 5. So we know right in the middle is our axis of symmetry. So it's got to be at 2. And let's see if we get the same thing here. To find our vertex from this, x equals the opposite of b over 2a. So that would be 2 over 2 times 1/2, 2 over 1, so it's at 2. And then y equals 1/2 times 2, 2 times 2 minus 2.5. So this would be 1 minus 4 minus 2.5. So -3. Oh, this was 2 squared, though, right? Because it's 1/2 x squared. Okay, I thought something was wrong. So 4/2 of that is 2. So 2 minus 4 is -2. Minus 2.5 is -4.5. So our third form, vertex form, y equals our a value, 1/2 x minus 2 squared minus 4.5. So 2 and 4.5, 1, 2, 3, 4.5. And then we need to find our y-intercept. I think the easiest is to plug in 0 into standard, but you could plug it into any one. 1/2 0 squared, 2 times 0 minus 2.5. So it's at -2.5, and we could then make another point using the axis of symmetry. So it's 2 away, 1, 2 away. And then we have our graph. So on the next page, we're going to look at a couple more. But let's rewrite this one. We're going to graph y equals -4x squared plus 16x minus 12. So it's in standard form. So let's try, here's standard. Let's say we want to get it into factored form. Well, let's see. So we have to factor it. So what multiplies to 48 and adds to 16? 12 and 4. So plus 12x plus 4x minus 12. And if we factor it, let's see. I want to make that x positive, so let's pull out a -4x if we're factoring by grouping. So this is x minus 3. We could take out a +4 and we have x minus 3. So it factors into -4x plus 4 and x minus 3. But if you guys will notice on intercept form here, there's that a pulled out. It's always just x minus something. So we have to pull out a -4 from this one. So if we pull out a -4, then it's going to be x minus 1 times x minus 3. All right, so our intercepts here, if we're to start labeling this, so our x-intercepts would be at x equals 1 and x equals 3, 1 and 3. Okay, and then our y-intercept, well, let's see if we plug in 0 here, negative 4 times 0 squared plus 16 times 0 minus 12. 0 and negative 12, which something's got to be off here. Let's take a look back, because 0 and negative 12, that makes absolutely no sense that our y-intercept is not in the middle. So let's check out this factoring again. 12 times 4 gives you 16. If we factored out a negative 4, that works. If we factor out a 4, I'm not seeing what happened here. Oh, I know what it is. We're doing okay. This is a negative parabola, so it's facing down, okay? So we still need to find our vertex here. Sorry about that, guys. See, you gotta kind of think about what this looks like, and we know it's facing down. So our vertex, well, it has to be, our x-coordinate has to be 2, and we could get that two ways. We could look it's in the middle, or we could say the opposite of b over 2a. So negative 16 over negative 4 times 2. And then we plug it in. So y equals negative 4 times 2 squared plus 16 times 2 minus 12. So let's see, negative 8 plus 32 minus 12. So we got 24 minus 12, so it's 12. We could also plug it in here too if we wanted to, or we could plug it into negative 4, 2 minus 1 times 2 minus 3. And we should get that exact same thing there. So we got 2 and 12. I feel like my math's a little crazy right now because I don't think we aren't getting the same thing there. Let's double check this. Negative 4 times 2 squared plus 16 times 2 minus 12. Well, 2 squared is 4. Oh, this should be 16. Wow, the math is not going well today. 16 plus 32, so 16 minus 12 is 4. And that's what we would get down here. So 2 and 4. Whoa! And then you could say, well, here's our axis of symmetry. So this one is 2 away, so there'd be another coordinate over here. And then you have our graph. So let's take a look at this last one here. Well, what is our vertex? That one's easy. So our vertex is negative 2, negative 1. But we need to get this into standard form. So we have to multiply this out. And again, so if we multiply it out, this becomes negative 2x minus 4, x plus 2 plus 1. So let's see, we got negative 2x squared minus 4x minus 8 plus 1. So y equals negative 2x squared minus 8x minus 7. All right, so we know our vertex is negative 2, positive 1, excuse me, because our y stays the same. So here's our vertex. We know it's facing down. And then we have to find our intercepts. Well, let's see. Multiplies to negative 14 and adds to 8. Let's see. 14, 1, 2, 7. Well, that doesn't happen. So to find our intercepts, we'd have to use the quadratic formula. But we could find our vertex, our y-intercept. That would be pretty easy to do. So if we plug in 0, we end up at negative 7. So 1, 2, 3, 4, 5.